App packaging is a heated topic on Linux these days. On one side, you generally have the defenders of flatpaks, snaps, and app images, and on the other side, you've got the defenders of the good old distro packages. And I already talked at length about the advantages and drawbacks of these formats, but there are still a bunch of preconceived notions floating around on how secure these packaging formats are, on verified applications, on the sandbox itself, on dependencies, and other things. So I thought I would do a little bit of myth busting on these topics, pointing out the real facts behind all of these different formats, and I also thought I'd let you know about our sponsor. This video is sponsored by SquareSpace, your all-in-one platform to create, publish, and manage your own website. Squarespace has really easy tools to make sure anyone can end up with a nice-looking, well-optimized website, no matter if you know how to code or not. Squarespace has what they call their blueprint system, which lets you pick from a variety of templates that are pre-built and will suit any type of website. And they even have the SEO tools you need to make sure your website doesn't end up in the last page of Google's search results. To go further, Squarespace has their own design engine to create your own pages. You can just drag and drop elements where you want them, and you can change the colors, the fonts, and just tweak the template however you want. And then you can add some extra features like creating your own online shop with a complete payment system. You can design your own logo from Squarespace, book your own domain name. So click the link in the description below to give Squarespace a shot, and you'll even get 10% off your first domain or website purchase. Okay, so let's get the big topic out of the way first. App verification, how safe it is, and how it works. We've seen verified apps pop up on FlatHub and on the Snap Store for a while now. This is a great addition. It lets you know that the package you're downloading and installing comes straight from the developer of this app, and it hasn't been packaged by a random third party you don't know. It is an implicit guarantee that this thing is as the developer intended. No feature has been arbitrarily removed or added by someone else. You're getting the experience the app developer wants you to have. It's also great for the developers because it means that they control the experience and they have an easier time reproducing bugs and fixing them. What app verification isn't is a guarantee that the application itself is safe or secure and that it has no vulnerabilities. The way app verification works on FlatHub, for example, is that the developer either links their GitHub or GitLab repo to the app listing on FlatHub, or they had a little text snippet on their official website that FlatHub can check if the website is legit and is the right one for the app, or if the code repo matches the app, then there you go, the app is verified. But it doesn't mean the code that is in the package is safe. If the repo has been hacked, if there's a backdoor in the application, if the app itself is malicious, then the package you're downloading also contains that malicious code. We've seen things like this with the XZ library, for instance, where a maintainer had infiltrated the project by contributing normal code and slowly added a backdoor to the library. No one suspected a thing, and you could have had a verified version of this library at some point with the backdoor inside. App verification doesn't mean the app itself is safe and secure. It just means that it comes directly from the developers. You still need to trust those app developers to have built something that is safe and won't hack your system. Linux Mint, for example, seems a bit confused by this, or at least didn't convey properly how this works. They recently announced that they would hide unverified flatpaks by default, stating that they are a big security vulnerability. But the wording around this lets people believe that verified flatpaks are safe, which isn't necessarily the case. Where app verification really matters is when you want to get the app as intended by the developers. You know it's the developer packaging it. A recent example is the maintainer for KeePass XC on Debian, who decided all on their own that some features were not needed and removed web browser integration for the password manager. With a verified app on FlatHub, you don't have these problems, but it doesn't mean that the app you're installing is 100% safe. And if you're thinking, I use native distro packages, so I don't care about all of this, well, we have a little myth busting to do as well. The general view of distro packages is that they can be safer, because there is a trusted maintainer that will create the package and thus can detect any unwanted change, backdoor, or problem, and will prevent you from getting uninfected or buggy version of the package. This is really not the case though. Maintainers can do this, and sometimes do, but there are a lot of cases where all of these things slip through undetected. The XZ library, again, is the perfect example. Every single distro that packaged and shipped XZ let this backdoor slide in undetected. Of course, maintainers cannot be expected to conduct security reviews of the entire codebase of each project. But this is what some people seemingly believe about distro packages, that the maintainer is an extra buffer that will make sure no weird code or infected stuff will make it onto your system. This is not the case. It doesn't happen in most cases. If you look at log4j, if you look at the recent SSH vulnerability, if you look at the XZ backdoor, and basically every CVE ever discovered, it points to the fact that maintainers do not do code reviews on most packages they build. This is not what is expected of a package maintainer. Their job is to make sure the program being packaged integrates with the distro, is plugged into the right places, calls the right dependencies, and that the thing runs properly. It is not to conduct a security audit of the code. A lot of maintainers aren't even developers and could not conduct these audits in the first place. This is a common misconception. Distro maintainers very rarely enhance the security of an application or library simply by doing the packaging for that program. If an official Flatpak has been infected by malicious code, chances are the native distro package will have the exact same problem, even if there is a maintainer building that package. Another big misconception is around the sandbox for Flatpaks and snaps. A sandbox basically just means that the app you're running has a system of permissions that limits what the app can do and how it can interact with the system. It can be more secure than not having a sandbox, but it doesn't mean it is always more secure. A Flatpak package, for example, might have all permissions turned on, meaning the app has access to the entire drive, your home directory, the internet, all executables, configs, basically everything your user has access to. This would be the default state of something you install through your repo packages. You install the package with admin privileges, and then you run it as your user, and the app has all the same rights as your user, meaning it can download things on your system, run these downloaded things, modify and delete files, and everything else. Of course, for distro packages, you have security profiles provided by AppArmor or SE Linux and things like that. Now, a Flatpak and a snap can have some of these permissions enabled or disabled, and depending on that, this application, this package, will be more or less safe to run on your system. That's why you can check on the permissions of each Flatpak before installing it, and you can enable or disable these permissions. You need to be able to see and control what the app can or can't do. As far as I know, snaps don't have a graphical way of changing these permissions, but correct me in the comments if something like that exists. Another example of the sandbox not doing anything to protect the user is with the recent scam crypto apps on the Snap Store. These were sandboxed applications. They just scammed you through a web view, a website, basically. They didn't need access to anything other than the internet connection, so the sandbox here didn't mean the app was safe. And that's why we probably always will need humans to check these submissions onto FlatHub or the Snap Store. That's where distros' repos might have had an advantage, because a human maintainer would have had to package the scam app, and there's no way they would have done this after using it for like 2 seconds. So here, for example, distro repos will very likely have less intentionally malicious applications. Another common misconception around packages is how dependencies work. You will often read that distro packages use the system dependencies, and thus use less disk space, but also are more secure, because you know that the library the app relies upon is updated by your distro, compared to a Flatpak, to a snap, or to an app image, where the developer might have bundled a dependency on their own and never really bothered to update that version. In theory, this is true. Flatpaks, snaps, and app images can and sometimes do come, especially in the case of app images, with pre-bundled libraries that aren't shipped as part of a shared runtime. And sometimes these bundled libraries can be left unmaintained and unupdated by the app developer. That's true. But when you dig a bit deeper, it's not as clear-cut, as in, the distro packages aren't necessarily better. First, you can check which versions of dependencies your flatpak comes with. A flatpak is open, you can see how it is built. There's generally a manifest file that lists all the bundled dependencies. Bundling things this way is also not really a recommended practice. Flatpak recommends you use runtimes, which are shared libraries between flatpaks. They save space and they are updated independently of the application, so chances are they're more up-to-date and safer. Second, distro packages aren't always up-to-date either. Just because it's a shared library doesn't mean it has all the latest security fixes. Plenty of distros stick to a fixed version of a library. They will update that version if it doesn't break the system or the other packages. But if it does break things, then they will instead backport security fixes to the current version. This is manual work. They take patches from newer versions and try to retrofit them to the older version that they ship. And this isn't always possible. Sometimes the patch simply cannot fit on the older codebase, or it is just too time-consuming to rewrite things around the fix that will not affect most people. It also means the maintainer needs to know how to code and how to potentially apply a patch and recompile things in their package, which is not always the case. Not all maintainers are developers, and not all of them have the time to do all of this backporting work. So sometimes when the upstream library or app just doesn't provide these security fixes for older versions, you're just not getting them in distributions that have fixed package versions. This example will be clearer. MariaDB got a security update in 2021 in November. Arch and Artix updated things the same day because they generally tend to always move to the latest version. Debian took 3 months to apply this update, and Alpine Linux took 4. Same goes for fixed Linux kernel versions. When your distro is locked to a specific kernel version, it's been factually proven that this version becomes more and more buggy and more vulnerable over time. Maintainers simply do not apply every fix and do not backport everything. For example, the current Red Hat Enterprise Linux 8.8 kernel has more than 4,500 bugs open that have fixes in later kernel releases. Those fixed package versions in the repos aren't here to be safer. They're here to offer a stable base for your entire system to run. Everything has been tested in accordance with this stable base. This can and sometimes is less safe than getting the direct upstream version of a new library and a new application. It is also potentially more stable. Flatpaks, snaps, and app images can and do have old bundled versions of libraries that aren't updated, but your repos also often do have the exact same thing. So, I hope this provided some context and some facts about how packages are made, how safe they can be, and various problems we have with all of our packaging efforts, no matter if they are distro packages, a containerized format, or something else. It is important to remember that in the vast majority of cases, distro maintainers and packagers are volunteers, individuals. They might not know how to code, and it is not their job to conduct security audits to verify that the code they ship is actually safe. Their job is to make a package and push it to the repos and ensure that this package doesn't break everything on your system. Distro packages are not necessarily safer than a third-party flatpak or an official flatpak or an official snap. These formats come straight from the app dev, but it also doesn't mean they are 100% safe, whether they're sandboxed or not. Ultimately, it is always your responsibility as the user to check that what you install is safe enough and that you're comfortable using it. Whether it means looking at the source code if you're capable of that, or looking at the permissions, disabling, enabling what you want, looking at who built the packages, it is your responsibility. And this would also be true on iOS, Android, Windows, or macOS. None of their distribution methods are any safer than anything we do, and you often hear applications being hacked or malicious apps going through these stores. It's not a Linux-specific problem, we just have more packaging formats that have more different problems and issues. So hopefully this dispelled a few misconceptions around packaging formats, security, the sandbox, and everything else, and hopefully you'll listen to this segue to our sponsor. It's Tuxedo Computers. If you're looking for a new PC, whether it's a laptop, a desktop, a small form factor, NUC, or whatever else, and you want to use Linux on it, and you want to support a company that actively contributes to Linux, click the link in the description below and give Tuxedo Computers a shot. I only use their devices these days. They have a wide range that will cover every price point and every need. They are based in Germany, but they ship to most countries in the world. And me personally, I run my entire channel on one of their laptops, which you can all open, repair and upgrade, and I do all my gaming on one of their small form factor PCs. They're really solid devices, so click the link in the description below if you want a new Linux PC. So thanks everyone for watching the video. I hope you enjoyed it. If you did, don't hesitate to like, to subscribe, to turn on notifications. And if you really enjoy the channel, there are also some links in the description to support me financially. And you'll get a bunch of perks in the process. So thanks for watching, and I guess you'll see me in the next one. Bye!